I would have thought the liver could maybe be better shown as like a waste treatment plant or a recycling centre, but you know, a strip club, it works too. Hello, welcome back to the channel. Today we're continuing our look at Cells at Work Code Black. It's set in an unhealthy body, so an unhealthy workplace for these cells, and it's not a great place to work, and that's why it's called Code Black, because they refer to a black company in Japan as a company that doesn't treat its workers very well. This episode is about alcohol, and I'm guessing if it's anything like the manga, it will also feature a strip club, so viewers' discretion is advised. This isn't for everyone. But if I know the internet well, just by me saying that, I think many more people will be more interested. The red blood cells have been given more places to visit on their travels to symbolise them working harder, and we touched on this in the first episode. If we have an increased metabolic demand on the body, we're going to need more oxygen and to get rid of waste products as well. So our heart rate's going to increase, meaning the red blood cells are going to end up circulating around the body a lot more. Hence, they're going to be visiting more places. So this kind of list of more places for them to go, it makes sense. Also, in the last episode, I asked you guys why the red blood cell is called AA2153. I didn't think it was for a physiological reason, but you came up with some great suggestions. So you thought the AA may relate to the blood group, so the major antigens that are on the surface of the red blood cells, which is really nice thinking. But also what many more of you pointed out is that if you take AA2153 as a hex and see what color that comes out with, let's see here, it is red. Pretty cool. And for someone with a degree in computer science, I'm ashamed I didn't spot that. Way! And we see the macrophage. Big fan of the macrophage. Macrophage literally means big eater. Macro, big, phage, eat. Because when they see a bug, they go through phagocytosis, which literally means phago, eat, cytosis, breaking down cells. And the cells they break down here are pathogens, so germs like bacteria, viruses. I may as well explain everything today. So pathogens, path means disease, and gens, something that causes it. So pathogens are disease-causing agents. Neutrophils are the other white blood cell that we really think of as phagocytes. And together, this phagocytosis is a key part of our innate immunity, so our built-in immunity to handle pathogens. But it also is linked in with our adaptive immune response, so that these pathogens can get signaled, so they can get antibodies slapped on them, and that opsonizes the bacteria, which means they look more tasty to our phagocytes here. And very important here that the macrophage is actually taking the bacteria here, so it's going to be breaking down to pick out these proteins that we call antigens that then kicks off this adaptive immune response. So these antigens will get cycled through the immune system and therefore will produce antibodies and T cells that are able to recognize this bug if it comes back again. It's worth noting here that the immune system is not an intelligent system. By that I mean it doesn't think about what's the best way to attack a certain pathogen. It basically just works on this flow diagram, which is pretty complicated, and I don't think we fully understand it, but based on the type of damage happening and the cell response, different chemical messages called cytokines are released, and a different immune response gets generated. And that means that the immune response isn't always going to be the response you want. Look at something like COVID-19 and this secondary inflammatory reaction that we're becoming all too familiar with. Cool. I didn't expect to see a mouth ulcer. So I've been reading the manga as well, so spoilers, I'll kind of know what's happening a bit, but you get loads of extra things in. I think in the manga you get a lot more sort of depth of detail, but in the anime you get a little bit more storytelling, a bit more breadth of things going on. So we see here a aphthous ulcer, or often just called an ulcer. We probably all experience these, and we actually don't really know what causes them. They are the result of, were thought to be the result of T cells. So we've seen T cells and cells at work going a little bit mad, but apart from that, I don't think we really know. So they kick off an inflammatory process. And the burning here is accurate because you're either going to get some burning from these kind of inflammatory response by these T cells and other cells of the immune system. Don't forget, they're great at killing pathogens, but can also do as much damage to your own body.
Sure. 変形の境界がはっきりした浅い海洋はアフタと呼ばれる。ストレスや睡眠
Okay, apparently often caused by stress, sleep deprivation, and lack of oral hygiene. I didn't know that. I can't really think how those type of things might directly result in, your immune system, things like T cells creating ulcers, but the body's a complex thing, and particularly things like stress and sleep deprivation can have widespread health problems that we don't fully understand. Also, really cool here, look in the background of this shot. The walls here, they are squamous epithelial cells, the ones we find in the mouth. So all the tissues in your body are pretty much made in the same way. They all have a basement membrane and then epithelial cells on top. So this is the type of structure we see in the skin, in the gut, in the kidneys, all types of organs, but the size, the shape, and the actual inner workings of these epithelial cells will change depending on the function of that particular organ. And we know we're in the mouth, so these will be stratified squamous epithelial cells. The stratified bit means they have multiple layers of epithelial cells, and that's because in the mouth we want to protect the lower tissues from any mechanical trauma that you'd get from chewing your food.
口腔粘膜口の内側にある粘膜 So the
mucosa is also known as the mirror reflecting one's physical health. I've never heard of that phrase before, but looking in people's mouths is a part of the respiratory examination, the cardiac examination, the abdominal examination, so pretty much any kind of general medical examination. So there's lots of things that we can pick up when we look in someone's mouth. So although I've never heard of this phrase, it makes total sense. So a little quiz for you at home. I want you to leave a comment with a sign that you might find in the mouth and what disease that might indicate. Here come the pathogens. We know who this guy is. This is Strep pyogenes. We saw him in episode 2. And it looks like an even more evil version of the one we saw, which kind of makes sense. You can have strains that are more virulent than others. And to remind you, in Strep pyogenes, this tail here, this string-like tail is representative of the colonies that a Streptococcus bacteria grows when it forms. The yellow bacteria we've not seen before, he also has this chain-like structure, so it's probably another Streptococcus. So maybe something like Streptococcus viridans, which we haven't seen before and is very commonly found in the mouth. White blood cell, as always, to the rescue. Worth noting, I've said this a few times, but the white blood cell here is, a lot smaller than the bacteria. But in real life, the neutrophil is around about 10 times bigger than a bacteria, so would make it much more easy to phagocytose it and eat it. So here we go, we get a bit more information on phagocytosis. We see the white blood cell literally eating the bacteria, sort of chomping it up, but as we said, this wouldn't happen in real life. As we said, the white blood cells are much bigger than the bacteria, so it wouldn't be a kind of like chomping little bits of it. It would actually surround and engulf the bacteria and take the bacteria into its cytoplasm in a little kind of bubble called an endosome. The white blood cell also has other bubbles in its cytoplasm called lysosomes, which have digestive enzymes in, and it introduces these lysosomes into the endosome to make an endolysosome, and this breaks down the bacteria with these digestive enzymes. And that's where the bacteria meets its maker. Here comes the alcohol. It says here by temporarily improving the circulation. That's how it helps to take away some of your tension. I wouldn't say it improves the circulation. Your body is trying to regulate the circulation, but alcohol is a vasodilator, so it kind of messes with it. So it means you get more blood flow to kind of areas you don't need it. So your kind of skin and muscles, and you know, that's why you get a beer jacket. That's why you feel warmer, because your warmth is spread out through your whole body. But this also has a knock-on effect, right? Because this will drop your blood pressure, which means your heart rate will increase to compensate for that. So again, doesn't improve your circulation, just gives your body more things to sort out. The other cells are gonna get pissed. That's not a medical term. And we arrive at the liver, which, as they've said here, has a multitude of functions, and why they've chosen to make it like this neon kind of party high street to show its kind of activity, its metabolic activity. They summarize the functions of the liver really nicely here. So it has a synthetic function, so it produces lots of proteins, things like albumin, which is a carrier protein, so carries nutrients throughout the body. It also, just by nature of it being in the blood, this albumin keeps water within your blood vessels, so stops water leaking out, what we call oncotic pressure. And it also produces clotting factors, and we've seen these clotting factors a few times in cells at work when the platelets have been repairing wounds. It has an excretory function. By that, primarily, we're talking about bile, so it secretes bile into the biliary system, which then goes into the gut, and that helps to neutralize the food that's had the stomach acid in it, and it also helps to emulsify fat, so break up the fats to make them easier to absorb. And the other thing the liver does is detoxification of substances. Now, we've heard a lot of detoxes these days, eating weird diets and things, but you have everything you need to detox: the liver and the kidney. So the kidney can pretty much get rid of any single molecule that you'd ever put into your body, but there's two types of molecules it can't get rid of, and that's big ones or molecules that are fat soluble. So this is where the liver comes in, and at its most basic level, the liver can do two types of reactions. So a phase 1 reaction, where it takes a large molecule and makes it a smaller molecule, and a phase 2 reaction, where it takes a fat soluble molecule and makes it water soluble, what we call conjugation. So you can see how the liver and kidney work together to do a proper detox of the body. One thing they didn't mention as well, the liver is an important place to store things, most notably your energy, so glucose stored as glycogen, and also your fat soluble molecules, so that's A, D, E and K. Very quick interruption: if you're enjoying this video, you like cool things, you like the immune system, you want to support the channel, and you're also in a pandemic like me at the moment, then you can get some face coverings in lots of different colors: green, blue, yellow, pink. Thank you to everyone that got them so far and have tagged me in them on Instagram and Twitter. Always makes me smile. In this episode, we've seen the macrophage, so let me show you what she looks like. There she is, and also you can even show her phagocytosing some coronavirus there. So if you do get one, then send me a message to tell me if you've spotted all the different stages of the adaptive immune response. So on that note, it's back to the video. So the way the cells actually detox in this is by going to a strip club. Now, not very wholesome, is it not? Setting a great example. I actually remember this from the manga, and yeah, let me tell you, in that it's a little bit more graphic. I would have thought the liver could maybe be better shown as like a waste treatment plant or a recycling centre, but you know, a strip club, it works too. You know, we don't endorse this, but it makes for a more amusing story in the fictional world.
肝細胞、肝臓の70から80%を構成する細胞。物質。
And we meet the gorgeous hepatocyte. I almost completely forgot about the macrophage for a minute there. Anyway, we talked earlier about epithelial cells and how most tissues of the body are made from a basement membrane with epithelial cells on them. And the hepatocytes are the epithelial cells of the liver. And as you can imagine, they're packed full of the cellular machinery to make proteins, things like endoplasmic reticulum. This means that they can do their many roles that we talked about earlier.
その抜くっていうのは はいどうぞ
これは
これ
The cells are given a drink to. This kind of blows my mind. So the human drinks alcohol to get relieve some of his stress, and then he gets pissed off the back of it. Whereas the cells, therefore, when they get exposed to alcohol, have to drink ADH, which is actually the opposite of alcohol, but it's their equivalent of alcohol. The red blood cells get pissed from drinking their equivalent to alcohol that gets rid of alcohol. It's what?
ザ
This old dude, I mean, he said it himself, but it's total cringe. Pressurizing the young red blood cells into going to a strip bar and then taking ADH. But actually, in this scenario, the ADH they drink at the strip bar is kind of what they need to get rid of the alcohol. So it's a bit twisted that this is exactly what they need. We also need to be careful to clarify something here, because when I first read this, I got the wrong end of the stick. So when I first read ADH, I thought they were talking about a different ADH. So here they're talking about alcohol dehydrogenase, and that's the enzyme, as they said here, that breaks down alcohol into acetaldehyde. But alcohol also works on a hormone called ADH, which is a totally different molecule. That's antidiuretic hormone. So alcohol stops the release of this from the brain, and this hormone, antidiuretic hormone, as you could probably tell, works on the kidneys to absorb more water, so you actually pee less. So by alcohol restricting that means that you're going to pee more, and that's why alcohol is a diuretic, so it dehydrates you. So two different ADHs, very different molecules, but both linked to alcohol.
そんなこと言わないでグイッとね
あなたたちに
So we see the red blood cells getting a little bit leery, getting a little bit drunk, and that's because the ADH, so the alcohol dehydrogenase, has broken down the alcohol into acetaldehyde, which is a toxic metabolite. I've seen online people saying that acetaldehyde is the main cause of a hangover and selling you these miracle cures that if you eat them help break this molecule down, but actually hangovers are much more complicated than that. So they're probably a combination of the dehydration that we mentioned earlier, lack of sleep, so alcohol affecting your brain, or you've just not slept that much, the other metabolites that are in the things we've drunk, as well as just the alcohol, and you know, to some extent the acetaldehyde as well. So all of these things, multifactorial reason for feeling awful after a night out.
アセトアルデヒドにより脂肪の分解が抑制され脂肪肝を招く。その状態が慢性的に続くと
They briefly mention here cirrhosis, but we don't really see what that looks like. Cirrhosis is irreparable liver damage. So when we get damage to any tissue of the body, it can heal in two ways. So it can heal with complete resolution, which means the cells pretty much look exactly the same. So the organization of the tissue is preserved. And that's generally when the damage has been quite mild. But if the damage has been more severe, the body can't recreate this beautifully organized tissue. So it has to heal with fibrosis, which just throws a load of connective tissue down just to hold things together. So if we've got damage throughout the liver, and this can be lots of causes of cirrhosis, but alcohol being the main one, but other things include viral hepatitis, so a virus that can have a chronic damage to the liver. We'll get this fibrosis appear throughout the liver, and it will stop the liver doing its functions, which would result in liver failure.
じいさん
寿命ね
This here is actually very accurate. As we said throughout this whole series, red blood cells only live for 120 days. They've got no nucleus, so they'll slowly degrade over that time. And when it's time for them to be broken down, they are detected in either the liver or the spleen by the macrophages there and phagocytosed, just like the bacteria was phagocytosed earlier. And these particular macrophages that live in the liver we call the Kupffer cells, as we see here. And I like the inclusion here that the breakdown products from the red blood cells are used to make bile. We talked about bile earlier, it gets released into the gut. So in a weird way, it answers two very childlike questions of why is blood red and why is poo brown? It's all down to your red blood cells and them getting broken down. Red blood cell, totally busted. And that's why you don't go to strip clubs, red blood cell. So there you have it, another breakdown of what is such an insane but entertaining and educational show. I hope you enjoyed this. If you did want to support the channel, you can get some of the face coverings and learn a little bit more about what's keeping you safe with the cells and the immune system. And yeah, and as always, thank you so much for all the support on the channel. If you made it this far, why not subscribe, give this video a like. They help this channel grow, but as always, don't turn on your notifications, you know, just drop in when you're free. You don't need me pestering you. So until next time, I'll see you soon.